Can everyone hear me? Yeah, so hi everyone, my name is Siyi, and my presentation is about using NLP to extract salient user reviews. So I will start with some fun facts about online reviews. So 57% of customers will only use a business if its rating has 4 or more stars. 80% of 18 to 34-year-old customers have written online reviews, and 91% of 18 to 34-year-old customers trust online reviews. And a 1-star increase in Yelp rating leads to a 5 to 9% increase in revenue. So why is customer review important? So for business owners, review will help them better understand their customers and improve customer service. It will help increase business credibility and social proof. Reviews also appears to be the most prevalent ranking factor in local search. Positive reviews will benefit the business in advertising and branding. On the other hand, for customers, reviews will help you get some estimations and expectations before you went to some place. It also potentially establishes a relationship between customer and business. The customer will have their voice by providing meaningful feedback. So we know reviews are critical, but we have usually hard to find valuable and important information we need when we face tons of reviews and comments due to the information overload problem. So we can easily see some businesses or products with over 1,000 reviews. We don't get enough time to read it all. So here is why we need to use NLP to extract salient user reviews. So in today's talk, I will start by investigating the datasets, using NLP methods to clean and pre-processing the review data. Then I will briefly talk about how to do sentiment analysis and build a predictive model to predict review sentiments. Finally, I will do a simple text summarization and extract the most salient user reviews. And the data set I use is from Kaggle, which consists 1,000 reviews on a restaurant, 500 are positive reviews, and 500 are negative reviews. So most of them are unique. I give 2 examples of the most frequent reviews. Both of them appear twice in the dataset, the one for positive and the one for negative. And the image shows some sample reviews from the dataset with their sentiments 0 and 1. And for the review length of this dataset, the average length is about 58. The shortest review has 11 words, and the longest review is about 149 words long. And here is the example of the longest review, which talks about the price of a sandwich and the comparison with Subway. And the red 3 image show the length and frequency of those reviews. We can see the most frequent size is about 20 words, and most reviews are from 20 terms to 80 terms. So, and then I made a word cloud, which after the text cleaning to find what are customers' main concerns about this restaurant. So besides we say like never, bad, time, or disappointing in the negative part, and delicious, amazing, best, or friendly in the positive parts, seems like for both word cloud has significant show people talks about the place, service, and food about this restaurant. And in the data pre-processing part, so by removing the stop words, we remove the low-level information from our text to focus on the critical data. We also remove punctuations, numbers, since they don't help much, and they will increase the size of the bag of words and decrease the efficiency. We also want to do stemming, which takes roots of the words. Also, we want to convert all letters to lowercase. So I give a straightforward example. we can see we remove punctuations and we remove stop words like this, is, not, and was. We also convert like tasty or texture to root words for the third review. And after the pre-processing and the data, I want to explain the process of training and prediction for sentiment analysis. So in the training process, we take our review data as an input and its corresponding output text, which indicates positive and negative. So after the feature extractor transfer the review text input into a feature vector, pairs of feature vectors and tags are fed into the machine learning algorithms to generate a model. And in the prediction process, the feature extractor is also used to transform text input into feature vectors. And these feature vectors are then fed into the model, which generates predicted text about the positive and negative information. So the package I mainly use is called count vectorizer. So this package will help to convert a collection of text documents to a matrix of token counts. And for feature selection, we want to first take all the different words of reviews in the dataset without repeating words, which I showed in the slides are some features from A to Z. And to make the bag of words, we want each column for each word and each row for each review. So if one word appears once in a review, then it will be counted as one under a column of that word. For example, the third review, great way finish great. So great appeared twice. And in the third row of this matrix under the column of great, we will put 2 here. And lastly, we take the bag of words as X, 0 and 1 as Y, splitting and training the data. So the predicted results is an array with all 0 and 1s. And I tried several different algorithms to get the best model and calculate the accuracy, precision, and recall. So their accuracies don't have a huge difference. And multinomial has the highest accuracy for 77.67%. So to extract the salient user reviews, I mainly use TF-IDF methods. It's a statistical measure that evaluates how relevant a word is to a document. This is done by multiply two metrics, so how many times a word appears in a document and the inverse document frequency of the word across a set of documents. So by calculating the TF-IDF, I could give each sentence a score, and the sentence score will help measure the importance of each sentence. And here is a straightforward example of how the TF-IDF calculation works. So we could break down the calculation into following steps. We first want to count the frequency of each word in each review. Then we calculate the term frequency of each word. And before calculating the IDF matrix, we need to count how many times a word appears in the whole document. Then we follow the equation to get the log of the total number of reviews divided by the count of each term. So for example, the word good in the second review, we compute a log of 1,000 divided by 85, we will get 1.07. And the TF-IDF is pretty simple. We just use TF times IDF. By calculating the average score of all the words in a review, we could get the sentence score. Then just likewise, we also calculate the average score of all sentences in the document. We call that average score or threshold. And with this threshold, we could easily extract meaningful sentences out of 1,000 reviews. And by times K with that threshold, as K gets bigger, we will get a shorter summary with more salient reviews. So here is several screenshots of a restaurant and some review about it. So we can see we get some positive reviews that talks about the delicious taco, chips, and salsa. We could also find some negative reviews, complaints about the service and the quality of the food. And by using the TF-IDF methods, we could extract some salient user reviews with our threshold. So here are two example results of salient user reviews. The first one, we times the threshold with 2. We will extract the salient user reviews containing both positive and negative sentiments. And if we times the threshold with 5, we only got 2 sentences, which seems to be the top 2 importance reviews with the highest sentence score. So for different purpose, we could adjust K with the threshold and to get the most proper results. So in conclusion, by doing sentiment analysis and extracting salient user reviews, we want to help businesses and customers to make decisions and improve their efficiency. And yeah, that's all for my presentation. Thank you.
Thank you. At this point, we'll entertain any questions from the audience, please. Whether in the chat or if anybody wants to raise a hand, for example. Okay, in the meantime, while we wait, may we have questions from the panelists, please?
Oh, sorry, I was muted. I had actually a couple of questions, but I was wondering if you go back to the slide where you present the confusion matrix.
Yeah. Here.
Yeah, so yeah. So I think I had probably missed something. What are what's being kind of predicted, or like, you know, maybe explain the different entries of the confusion matrix and what kind of thresholds were used to compute these?
So this, I computed this like the results like 0 and 1 are like the sentiments of those reviews, which 0 is negative and 1 is positive. So the confusion matrix should be like the, so for true positive is like the orange low review is positive sentiments, and we predict it positive.
I see. And then so for like for some of these algorithms where the prediction is like a value between 0 and 1, do you use like a threshold of a half or something like that to decide if it's a positive or negative?
No, I didn't use the threshold. So I can use like the algorithm package from the scikit-learn from the Python.
Yeah, so those are actually learned from the data actually. So when we have the data, we already have some the label created by those people who manually go through all those reviews. Then they assign this sentiment like a positive or negative. So basically those algorithms try to learn those from the training data, then do the prediction on the test set.
I see. Okay, great. Thank you.
Thank you.
Thank you, Scott. Any other questions, please, either from the panelists or the audience?
I have a question about the IDF matrix. Can you explain a little bit more, like how you calculate that? I didn't catch that part. Yeah, like in this example.
Okay, so this part, like we make a matrix, like the x in X, we count each reviews. And in each row, it's like an array contains like each word in a review. So we first calculate the frequency of the matrix. So if like for the first review, it's like Wolf, Love, Place. So this is the first review after text cleaning. And like if there's a wall in this review, it can't be 1. So this is the frequency. And for TF, it's follow the equation on the left side. So the 0.33 is like you use 1 divided by 3, since there's totally 3 words in the first review. And for the document frequency, it's like this word appear like the total counts in the document, like in the whole documents, like Google appear 85 times in the whole document. So we put 85 here. And for the IDF, it's also following the equation. So N is the total number of reviews, which is 1,000 reviews in the dataset. So like you take log and of 1,000 divided by the DF, which is the document frequency. So like I gave the example of the IDF matrix for good. So it's log of 1,000 divided by 85, we get like 1.05. And the TF-IDF is you use the TF score times the IDF score. Is that answer your question?
Yeah, okay, got it. Thank you.
Thank you.
Thank you all. I'm afraid that these are all the questions that we have time for. Scott, please feel free to stop the recording at this time while we